So question number 10 says a mass is released from rest at position shown here at the top of this hill. What will the speed be as it goes past positions A and B? So we'll approach this question just looking at the idea of the energy of the system at each position. At the very top, we're going to say it has just potential energy due to gravity. At A, it's going to have also potential energy due to gravity, but less than it does initially. As well, it's going to have some kinetic energy at A. And then at B, it's going to have zero potential energy due to gravity, because we're going to say this is our height of 0 down at the bottom. And then it's going to have some kinetic energy greater than 0. So we're going to set up our equation that basically says potential energy due to gravity initially is going to equal the potential energy due to gravity at A plus the kinetic energy at A, which is going to equal the potential energy due to gravity at B plus the kinetic energy at B. Actually, you know what, I'm just going to get rid of this. That's 0, right? So we don't need to include that. So this would just be the kinetic energy at B. So let's go through this, right? So the first thing is we're going to find the velocity at A. And to do that, I'm going to use just these here because it's kind of what I have. So rewriting that's going to be mass times gravity times the height initially. It's going to equal mass times gravity times the height at A plus 1/2 mva squared. And this is what we're looking for, right? Our masses are going to cancel out. And then writing this over, GH equals GHA plus 1/2 VA squared. I'm going to subtract GHA from both sides, and then I'm going to rewrite this. So we're going to have 1/2 VA equals GH minus GHA. And the last thing is I'm just going to multiply each side by 2. All right, and then also I'm going to factor out my G here because it's the same in each one. So when I do that, my 2's cancel out there, and I'm just left with, squared, sorry. VA squared equals 2G and H minus HA. And then again, we're just going to square root here. So that's going to equal 2 times 10. My height is 7, and then 4, right? Okay, so 7 minus 4. Square root. So VA is the square root of, what is that? 3 times 10 is 30, 60. Square root of 60, which is 7.7 meters per second. So that's the velocity at A. And then for the velocity at B, I'm going to do the same thing. For 2, I'm going to find VB. And in that case now, I'm going to use this and this, right? Because that's going to be the simplest setup. So it's going to be, it's going to be mgh equals 1/2 mvb squared. Masses go away. I'm going to multiply each side by 2 as well. My 1/2s go away on this side with my 2. And I'm going to be left with VB squared equals 2GH. Square root both sides. VB equals the square root of 2 times 10 times 7. 70, so that's what, 140, the square root of 140. So it's just a little bit under 12. So it's going to be, it's about 11.8 meters per second. All right, so that's how we would set both of those up. Again, the main thing we need to be able to do is set up our main equation. Potential energy at the beginning equals potential plus kinetic equals kinetic. And then from that, I can work through either one.